Okay, so that was actually half an hour. I was blabbering for half an hour. I hope it helps. Um, and you'll see in a second the result of all that blabbering. So anyway, we came to this point here. So let's have a look at double pointers. What are they for? What are they for? And how do we use them? Okay, and we will check it here, and then we'll see what is the result of using this. This is basically just again printing out A and DD that we printed in here, but they'll have different values thanks to um, this function here. And by the way, when you make a function, it works in C, it works like this. First, you have to declare you're gonna have that function, okay? So it knows, it doesn't go crazy when it sees it here. Yeah, it doesn't say, oh, sorry, you're trying to use something that doesn't exist. It knows it exists, but it's not being implemented yet. First, you want to implement main, and then at the end of your function, you want to after main. This is where main ends. Then you want to create your function in C. And so it has to, this bit here has to look exactly the same as this one here. Yeah, but in here we expand and we actually implement it. Okay, so basically what we want to do is we want to use a double pointer, and I call the double pointer just because it is for you to see that this is a double pointer, but actually this says it. Yeah, if you see this, that means those two stars in here means this is a double pointer to an integer, which is shown in here. This is exactly, PTR1 is exactly what it is. This is the double pointer to an integer. It stores an address that goes to here, and then it checks it again, and it goes to here, and then there is an integer. 1 second, lads. Pause. Resume. Okay, works. Um, So what was I saying? Yeah, so that's a double pointer, basically. If you want to see how it looks like, obviously in memory, um, there are no arrows. The computer knows that if it's a, and see, computer C is very kind of, it has to know what do you mean exactly. You can't just pass some value and it knows, yeah, like in Python, you just write a assign 10 and it knows it's an integer. It checks that 10 and it thinks, yeah, you probably want it to be, you definitely want it to be an integer, because if you want it to be a string, you would put quotation marks, and if you want it to be a float, you would put a decimal point, blah blah. It knows. In C, you need to be very, very specific. So when you declare, sorry, an integer, it has to have this bit here. If you declare a pointer to an integer, it has to know you're declaring a pointer to an integer. Okay, so that's how C works, and that's how it's actually very, very easy for the computer to handle. It knows that PTR is a double pointer to an integer, so it knows what it has to do. When you do your magic with your double pointer, it knows when you type star PTR1, it knows it has to go in here and take this value. If you type star star PTR1, it knows it has to take this value, go to that value, sorry, look at this address, go to that address, look at this address, go to that address, and take this value, yeah? If it's 2 stars. If it's 1 star, it gives back this. If it's 0 stars, it gives this back. Okay, so it knows exactly what it does because it's so explicit. Okay, don't want it to be as long as the previous one, so let's jump right to it. So basically, there is something like global variables and local variables, and there's also addresses. And C, that's the power of C. You can have an address, and when it comes to address, if you look at this, I know it's just a depiction of a memory, but the memory is just like piece by piece by piece by piece by piece by piece, and it starts at 0 and it ends at don't know, 16 billion, because it's like 16 gigabytes. Um, RAM, let's say. So it has address after address after address after address, which starts at 0 and it ends somewhere, whatever is the length of that memory, whatever is the size of that memory. But if you want to, size is kind of like a length of, if you had like a line of addresses, that would be your memory. 1, 2, 3, 4, 5, 6, and 10 billion, 10 billion and 1, 10 billion and 2, and so on. It's just like bit after bit after bit after bit. Every bit has its own address. Okay? And the block, whenever you see a block of memory, someone says, oh, you need to allocate a block of memory. It's just more than a bit, probably. It's just like 4 bits of memory is a block of memory. For example, if you want to store an integer, which is like 4 um, 4-byte integer. That's going to be a block of memory of 4 bytes. Anyway, so let's go back in here. So here's your function. So as you remember in in um, in class, we spoke about passing by value and passing by reference. And the difference between passing by value and passing by reference is reference is absolute. If you give an address to something, that thing becomes an absolute thing for everyone and every function, basically. So in here we have a main function, okay, and in here a um, we have a pointer to pointer function, and this is a different kind of animal, and this is a different kind, not animal, but different kind of piece, body, whatever you want to call it, different entity, and it has different local variables, and this one has different local variables. So even though you assigned um, a in here to something, you declared and assigned a, if you had a in here, it wouldn't clash because it was a in there in main is a local variable for main, and a in here would be a local variable for pointer to pointer. So it's fine. It's relative. When it comes to addresses, it's absolute. So if you pass an address to something, then we can actually manipulate the thing that we share between different functions because we all kind of go to the same address. So if we want to manipulate, let's say in this case, dd, if I didn't put this in here, if I just put in dd and I change this to a single pointer because this is a single pointer, we would take this address, but we wouldn't have an address of dd. So we can't change dd anymore. We can only change whatever dd points to. Fair enough. But if we want to manipulate dd, we have to take, sorry, not dereference, we want to take the address of dd and we want to make it a double pointer. And why double pointer? Because dd itself is a pointer. So if you have an address to an address to a pointer, it becomes a double pointer. Yeah, it's straight enough. If you think about it, it's nothing else than just thinking how many fingers am I pointing? Is it one finger? Is it two fingers? Is it like how many guys is there? Imagine a pointer is a guy that points at something. And that guy in this case is pointing at, let's see here, dd is pointing at A. Yeah, we told him, hey dd, point at an address of A. So in short, point at A. Go there if I need you to give me something back, if I want you to be dereferenced, give me whatever is in A, okay? And that's a guy pointing at A. And in this case, in this function, I say, hey, whatever I pass into you, point at it. But by the way, that's going to be a pointer, okay? I tell this guy to point, okay? First star says point at, and the second star says a pointer to an int. Yeah, that little line here says a lot actually. It tells a story. It says, okay, that variable here that I'm gonna create in here, that's gonna be a local variable. that double pointer. It doesn't exist in main, it exists in here. What it points to does exist in main, and it does exist in here. So that's how we share it. But the double pointer will be only in here, and that double pointer in the story we tell in here is, hey guy, you'll be pointing at something. And that something will be a pointer itself. Sorry, I'm moving stuff. It's going to be a pointer itself. The second star says it. We're going to call it double pointer, and it's the thing it's going to be pointing at is an integer. It's a long story, isn't it? It's just like a short. Um, it's not even a sentence. It's just like two words basically, but it tells a story, and it's good to know it. The more stars we put in there, the more story we tell. We say, okay, it's going to be a pointer that points at 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 a pointer to an integer. Okay, but we don't want to go that far. I don't think it would be necessary in this case, and I know it wouldn't be necessary because it does the trick. And the trick in here is, so first we want to see what the hell we just created. Yeah, we're gonna see what this double pointer looks like. What kind of values does it have? What is the address of it? Do we have that address anywhere in there? Or maybe maybe the address of this guy is unique for the function, but this guy is actually something that we had before, and that's the case actually. And then we are gonna change something. So we're gonna double dereference if that's the word, or dereference the dereference. Basically, we're gonna go to the address of that integer we're looking at, that we said we're going to be pointing at the end of this pointing chain, we're going to be looking at an integer. So because we have two stars here and two stars here, you can be sure we're looking at an integer. Okay, so let's change that integer, whatever it is. Okay, we'll see in a second where it is. Let's change that integer to 75, let's say. And then let's create a new piece of memory. Let's call it temp pointer. And that's gonna, by the way, so what's happening here again? We create temp pointer in stack, yeah, only for the function pointer to pointer, yeah, just the local variable temp pointer, yeah, that local variable is only created for this guy. Whenever we finish with this guy, with this function here, that disappears, that being um, freed for the next function or whatever. But then we allocate some data in the heap, okay? So that's the heap thing. And that's gonna stay. That's gonna stay longer. After we are finished with this function in here, yeah, we called it, it's finished, we move here, temp pointer is gone, yeah, whatever it holds, but that allocated memory will stay, okay? And what we want to do is we want to put 101 in that memory, and then we want to take whatever, see, this is the single dereference, okay? This is 2, so we're going inside of that pointer. So basically what I'm saying here, I'm saying, hey, instead of pointing at whatever you were pointing before, and because we're passing dd in there, um, this is at the moment it's pointing at A, and we say no, that's it. We're not pointing at A anymore. We are pointing at this temp pointer, whatever is that temp pointer uh, pointing at, if that makes sense. So we change the addresses. Before dd, which is passing here. Sorry, I'm using dd. Yeah, dd that we pass in here. Before it held an address of A. Now we say no. Take this address. Take the address of that allocated memory and put in there. Okay, and we know we put 101 in that memory, by the way. Whew, I think I explained that, and then we run it and we put dd in there. So as I said, it had A before. We want to see what happened to A, and we want to see what happened to dd as well, because we manipulated, as you can see, we dereferenced that double pointer. We went to D and we went to A. We changed that. Okay, we changed A by using this. and you'll see it in a second. Okay, so let's compile it. Oh no, I did compile it. So I'm gonna just save this. And I'm gonna just run it. So pointers, enter, and it did something. Okay, let's go as far as here. I want to have a lot of, you know what? Oh no, we need a lot of space in here. So we want to see all the printed stuff. Okay, so let's go back in here. So we have A, and that A address, and you see how the address of stack is like a really big number. It's at the end of the memory. This is the end of the memory. This is the beginning of the memory. So heap, it will be always a smaller number. Okay. So and heap, where is heap? So sorry. So we are at A, and this is in stack somewhere, and the value is 89. That's fine, and that's what it says. That's what I asked for when I was printing. Yeah, and check it again over and over again. Rewrite it. That's gonna really clarify all of it. Okay, and because it works, I'll show you it works. So that gives you the confidence when you rewrite it. You won't be scratching your head thinking, did Mark make a mistake? No, you'll see I didn't. So if you have any doubts, probably you just have to kind of look at it from a different angle. Or maybe I made a mistake and let me know. Um, but I think I didn't. I went through it a couple of times. So character B, um, we assign J to it. Here is the address. C is a float, and here is an interesting thing. So here's an address. So whenever we declared C, it gave it automatically, it gave it some address in stack, but we never gave it a value. So it's like some random value, whatever was inside of that stack before. It was used before and it had some value. As far as I know, it's some sort of a magnetic kind of stuff that changes in memory. That's how it gets we store bits, zeros and ones, and there were some zeros and ones, and when you turn it into a float, this is what it is, and it's so-called a garbage value. So be careful with garbage value. You don't want to use that. Imagine you use that value somewhere in your calculation, forgetting about, actually initializing and actually assigning a value to it, and you get some crazy answers and you're thinking, why is that happening and why is it random? Every time you run it, it's going to be a different kind of, because it goes to a different memory. It doesn't always go to the same memory. Every next time I run it, it's going to be it would be a different memory, and different value would be in there. So um, it would be just random and crazy and would definitely make mistakes. And it's kind of sneaky, because when you make an error, when you make a mistake and there's an error, that's fine. It stops you from using it. But imagine you use um, a program that runs, it's fine, but it's using some garbage values. So be careful there. Then we have a pointer that was, as I said before. Let's go to that pointer, CC. Okay, we're looking at this line here. We So the computer created some space in stack. You see that big number. So we are in stack here. So this is where CC resides. Okay, this is where the variable that is an address variable resides. What it holds inside is an address to something we malloced in heap. And you can see this is so much smaller than this. Okay, this is hexa number, but it's so much smaller than this number. Okay, we read it after OX. Okay, this is so much bigger than this. And then I wrote this, I added this because we want to dereference it. So let's go in here, and we went to that address and we assigned there 10. So we dereference that way. This is how we dereference, and if you go down, you'll see to dereference, you just write this. Okay, star C. And we get in there and we get 10. And then the same with D. As you can see, this is stack and this is stack as well. So why is that? Before it was smaller, now it's bigger. So that's heap, that's stack. Why this is stack when we point to it? you can point to stack, as I said before. We just took an address of something that was in stack before, and we assigned it to this address, okay? So in here, and by the way, this line here, I know it's very confusing, this star thing. So in here, this says, give me an address to an integer. But then you don't use star anymore if you wanna assign an address to it. Then you wanna do just dd assign an address of a. Yeah. So in here, when you declare something, you declare it like this. Sorry, when you declare a pointer, an address, you declare it like this. And now the computer knows, yeah, that's an address, and you want to store an address in there. But then you don't use the star. When you use a star, you go to that address. So now you say, this is my DD, this is my address variable, and I want to store an address in there. I know it's confusing, but that's how it works. And just memorize it. Okay. And then, so DD, looking at A, which by the way, if you, did I, and if you double click this, on this is an address, and this in the box, so it's exactly the same value. You can compare it. Basically, it's looking, the value of DD is an address to A, okay? And if you dereference it, it's 89, and as you can see here, it is 89. Okay, EE, we malloc it, so it should be smaller number, and it is. It's in heap, and we take a value from B and we put it in there, okay? And we have J in there, and that's fine. That works. And then we get this string hello. So this is a bit trickier, a bit crazier, as I mentioned that the last time. So this is your string variable, okay? I call this string. You can see the name here. And then this is an address. Every time you declare a variable, it goes straight to stack. It doesn't get mallocked because you have to precisely say, I want to malloc something. Otherwise, it goes to stack. So that string, that variable, that is there is a pointer to a character, yeah, pointer to a character. String. Sorry, what am I saying? Yeah, so it's that variable is in there, and it stores this. So what does it mean? And it looks like a heap. It looks like it's a small number, so it has to be a heap. And why is that heap when I didn't malloc anything? So this is how string works. String is a bit more complex. String is a bit more kind of, it's actually very useful, very complex, kind of nicely implemented in C, but it's cryptic. It's kind of like made by the guys that knew what they're doing. They all agreed and they did it, and then the next generation came and they were like, why the hell did you do this? So it's kind of user unfriendly. So basically what it does is it checks the length of hello. It allocates 1, 2, 3, 4, 5, 6 chars somewhere. So it mallocs, it does this, but instead of char, it goes char and here times 6. Yeah. So we have space for 6 characters. Whoops. Control Z and Control S. And in here, yeah. And then it puts HELLO \0, and that's how it knows how to print it. Okay, so let's see how is it printed actually. So how to check the address of the pointer to that first character? It's here. Okay, that's grand. The address of string. Okay, what is in there? It's a pointer, so it has to be an address, so you can check the pointer in here. Okay, show me a pointer. Sorry, the second one. So this is the address, and that's the second. So this is some address where this first letter H is. Okay, then I want to see a character. You can see a character, it's pointing at the character, so you can take the character back. So you just have to dereference it. Okay, and you get H. Fair enough. It's the first letter, it's where we point at. But then, if you use combination of %s and string with no star or ampersand, you get the string. And that's it's not that crazy. It's not a rocket science. You just have to memorize it. I don't think it's that complicated. You just have to write it. To be honest, first I did think it's complicated. I was like, why the hell would you do that? But now, after making this code, I'm pretty confident that I think I know what I'm doing. And then we have an array. So as I said before, it's an address to a first element of that array. So when you declare an array and then assign something to it, you say, okay, that's going to be an array of, again, we're telling a story. It's going to be an array, and that's how you say it isn't going to be an array, by putting square brackets after a variable name, okay? So that's the first kind of sentence. It's going to be an array. Then we say it's going to be an array of integers, and then we say it's going to have 2 items in it. Okay, so that's the whole story we said in here. And then we assign some 2 items there that have to be integers, by the way. Otherwise, it's going to say, no, they're not integers. Leave me alone. Error. So that's where the pointer to that array, to that first item is. That's where is the first item, and we used A, and I hope it's the same address as A. No. What is wrong in there? Oh, sorry, yeah, no, this one here. So that's an array. That's... Ah, yes. Oh, that's funny. So the address of it, of that pointer, array2, is, sorry, simple array, is this. And that's also the value it holds. Doesn't make sense. How does that work? Doesn't make sense. Array, pointer, ampersand array. You see some crazy stuff happening. It shouldn't be like this. You agree with me, no? It should be this, don't you think? So there you go. Something I didn't know, something I thought I know, but turns out it's I was wrong. The address of A isn't store. Oh no, sorry, no, that's fine, that's fine. That's the address of, see, we're supposed to look, oh, I did that in here. So the address that is stored in array is this. No, hold on. Okay, I'll look into it. So some homework for you and me. Check how the arrays work. So I'm not gonna focus on this now because I'm confused and I don't want to waste your time. Let's check arrays and go back to it so we are thorough. We know what we're doing. And we get to free. And what happens after we free stuff? So we had CC in here. We had CC in here, and now we have CC in here. The same address, okay. Seems like it holds its address still, but there's no value in there. We had 10 before, and now it's 0. And you'll see in a second how really free it is by looking at this bit here, okay? So, okay, so we freed CC, it went to this address, it cleared it, and it said, hey everyone, it's free, you can use it, you can malloc it again. And that's what we're doing here. So we run this code. So let's go to that code, and we want to see what happened. So we put in DD, an address of DD. And as you remember, DD is an address itself. So we put an address to an address, which is double pointer. Okay, so we put a double pointer in there, and that double pointer points at the end to an integer. And you can see it in here, DD, address of A, and sorry, DD int. Yeah, so that's how you know exactly, yeah, we're looking at an integer. And you can see it in here. We can only store a double pointer to an integer in this case. Very, very restricted, isn't it? So we want to see, what are we looking at? We want to see, okay, that's the name of the thingy, and it's function variable. I called it function variable. I don't know why. It's actually the double pointer. So that's what we're looking at. And I called it double function variable because it's inside. We took dd and we took the address of dd, we put it in here, and then this function here, it created its own variable called double pointer. So that should be double pointer actually. And it has its own address that is unique. See, I double clicked on this. I'm looking here. None of the addresses is highlighted. Okay. So it seems like it's unique, and it is, and that's how we limit ourselves when we create new functions. When you have a function in a function, you have to remember they have both their own unique local variables. They create them themselves for their own purposes, and then they clear them after they're finished. Okay, but this guy here, so this is our double pointer. It is in there, it's unique, it's nowhere else, but it holds something. It holds the address of dd. Yeah, that's what I said before. I said take the address of dd to that function, and it worked. So we're happy enough. Everything works the way it should. What else do we have? So that has, so the address, the value, and the reference value is again a pointer because it was a pointer to a pointer. So now we have an address. That's the address of dd. That dd holds this address inside of it. That's the value of dd. Okay, and let's make sure. Yep, that's it. That's exactly the same. And what is it actually? I remember I assigned the address of A, and that's it. Okay, and it's 89. So then what I'm doing in here, I want to double dereference that double pointer and change its content to 75. So I'm hoping I'm changing here A to 75 from 89 to 75, and then I'm creating a new space in memory, and I give it 101, and I say from now on dd, you're looking at this address instead, sorry, this address that we malloc there, so new memory. And it's not going to be a anymore. It's not going to be an address of a anymore. And look here, the last line of my main function in here. It's last 2 minutes, I promise. We want to see what A and DD holds. So let's compare A. A has the same address. We never changed the address of A, but we did change by using the double pointer and double dereferencing. We managed from outside of our main function to change the value of a local variable A, just because we had this absolute knowledge, the knowledge of the absolute address of this variable. This is pretty neat. This is pretty powerful. Okay, and now let's look at this address. dd is still in the same place because we don't move the actual variables from place to place. They stay in one place. If they're called and never cleared, they stay in the same place. But we knew that it was before it was looking at the address of A, but now we malloced it in our function pointer to pointer. We malloced it. We malloced something and then we pointed at this malloc. Yeah, we assigned that address to our dd, and now it's looking at this. And by the way, it's an address that we just cleared. We just freed it. It wouldn't be here if I didn't free it before. It wouldn't be used. But because I freed it, it was the last thing that became available, and it was just waiting for the program to malloc it again. Okay, you get it? So this is what freeing means. If I didn't free it, that number would be different than this and this number. And you can check it. If you take my code and you change this, and if you just put this you'll see a different number. Okay. But I want to do that, and that's it. And then we have value 101, yeah, that we assign in here. So this is the crazy program I made that helped me to understand how pointers work and double pointers, except for arrays. I still don't get the arrays, but I'll look into it. But it clears a lot, and it kind of gives you a lot of practice. And if you actually just rewrite it on your machine, um, and run it and change the values of it and run it and rerun it. If you look here, I'm gonna rerun it. The numbers change every time I rerun it. The numbers change, and you can see that garbage value, as I said before, it changes as well to some random numbers, the same as the stack, the all the addresses. Okay, I hope that gives you an idea, a better idea. I know everyone had some idea. It's not that kind of crazy hard to understand, but I remember I always felt this lack of satisfaction when it came to pointers before I did this. So I hope if you had this lack of satisfaction before, I hope this little program helps. Okay, thanks for watching. I know it was long, so really appreciate it, and chat you soon.